All right, let's look at the homework 13.2, problem number 5. All right, so we have two curves and we want to find the point of intersection. All right, so let's do that. All right, so we're just going to match, corresponding coordinates. So we have t is equal to 8 minus s, and also 3 minus t is equal to s minus 5. All right, and the last one is 48 plus t squared is equal to s squared. All right, so what I'm going to do is first equation and the second equation is essentially the same equation. So I'm going to use the first equation and plug it into the third equation. All right, so let's do that here. So since it's already solved for t, so I'm gonna plug 8 minus s into here. All right, so we're gonna get 48 plus t squared. So I'm gonna do 8 minus s squared is equal to s squared. All right, so I'm gonna just multiply out the square here. So you have a 48. And 8 squared is 64 minus, let's see, 16s plus s squared is equal to s squared. All right, then we can subtract s squared from both sides, so we can just cancel those out, and that becomes 0 here. All right. Then we can just try to solve this equation for s. So we're going to just combine those two. 4 plus 8 is 12. And 6 plus 4 is 10. So it's going to be 112. And then I'm going to move this over to the other side. So I'm going to add, let's see, 16s to both sides. So we have 16s. All right, then we can just divide through by, because we want to isolate s, divide through by 16. So let's see, 112 divided by 16 is actually 7. 6 times 7 is 42. Yeah, so that will be 7 is equal to, all right, so we know the s value. All right, so once you know s value using the first equation, 8 minus 7, t is going to be equal to 1. All right, so we can use either equation. Let's see, we didn't really have to. Since I already found t, so let's use the first one. All right, so first coordinate is t, so it's 1. Second is 3 minus 1, so it's 2. All right, third is 48 plus 1 squared, so it's a 49. All right, so let's type it in. So we have 1, 2, 49. All right, so I'm going to go ahead and check the answer first. Submit for testing. All right, it came back and looks like we got the point of intersection correctly. All right, so we want to find the angle of intersection now. All right, so let's do that. All right, so we have to find the direction vector for the first one and the direction for the second one. All right, so direction vector would be simply the derivative. So r1 vector prime of t is equal to, all right, derivative of t is 1, and derivative of 3 minus t is negative 1. And derivative of 48 plus t squared would be 2t. All right, and since we're looking at the intersection point is when t equals 1, so I'm going to call this guy v1. This is going to be, so we plug in t equals 1, so it's going to be 1, negative 1, t equals 1, so 2 times 1, so it's 2. So that's the direction vector for the first guy. And then for the second one, so we take the derivative. Yeah, then you have a derivative of that with respect to, actually, these are written in s instead. So I should probably use s there. All right, so it's going to be derivative is -1 and derivative is +1. Derivative of that is 2s. All right, and this is going to be equal to, actually, I'm going to call it the v2 direction vector at s equals 7. So you have a -1, 1, 2 times 7 is 14. All right, so we have that. All right, so we need to compute, so the angle theta is going to be arc cosine of, all right, so we have to take the dot product between V1 and V2, then divide by the magnitude of V1 and also the magnitude of V2. All right, so let's compute this. So we have arc cosine of, all right, so let's do the dot product. So you have a -1 times -1 is +1. 1 times, oh, actually, sorry, I'm doing the wrong one. I have to do those. 1 times -1 is -1. And -1 times 1 is -1. All right, 2 times 14 is 28. All right, so divided by, all right, so the magnitude of V1 would be square root of, all right, 1 squared is 1, -1 squared is 1, and 2 squared is 4. All right, then square root of, all right, and -1 squared is 1, and 1 squared is 1. All right, 14 squared, what's 14 times 14? All right, 4 times 4 is 16, and 1 times 4 is 4, so it's 5, 50, and 1, 4, so 196. All right, so it's a plus 196. All right. All right, so I'm going to simplify just a little bit, then I'm going to just pull out GeoGebra. All right, so subtract 2, so you have 26 over, all right, square root of 6 here, and you have a square root of 198. All right, so here I'm going to just go ahead and pull out the GeoGebra. All right, so here's the GeoGebra. So I'm going to just type in a arc cosine of, all right, then we have to plug in 26 divided by, and then we have to put the square root of 6, and also times square root of 198. All right, so hopefully this is okay here. All right, then hit enter. All right, it came out to be about 41 degrees. So this is about 41 degrees. All right, so let's check the answer. All right, I'm gonna say nearest degree, so it's 41. All right, so I'm gonna go down and submit for testing. All right, I came back and looks like we got the angle correctly. All right, that's it. I hope that this was clear.